Equations with variables on both sides. What do you guys think both sides means?
Both sides?
Both sides of what?
The equality.
The wall.
The wall of equality, right? Both sides of the equal sign is what we're going for, okay? So we're just going to jump into examples.
Someone's at the door.
Okay.
Zachary doesn't have her key.
I'll get it. Okay. Just a second. Thank you for letting me know.
Yeah.
That's all I think you could do.
It's okay.
Wait,
All right. So back to our recording. I'm going to put up an equation here. And right away you'll notice that it's different because it has variables on both sides of the equal sign. Right? So we're still going to draw our wall of equality because that's our organizational. Something happened. They won't tell me what was said. I was setting up the recording, so they're all still Googling about it.
what I said.
I don't know what happened, but we got the giggles.
So bad. There's no need to worry about it now.
Don't focus on the past.
Okay. So, up until this point, if I wanted to rearrange this, how would I move so that all my variables were on one side? How would I move numbers from one side to the other? What was the rule? What did I have to do? Daniel?
You can move negative 7W to the other side.
I could, but I need all my variables on one side and all my values on the other side.
Oh, then move negative 2W to that side.
Okay, Henry, how do I do that? What's the rule? How am I going to move this?
You just move it.
I asked Henry, what do I have to do?
You add them together.
I'm going to use my inverse operations and add. So I have to add 2W to both sides. Are you okay, Alex?
Yeah. No,
Okay.
I think it's like
So now I've got 15 equals negative 5W. Because I got rid of it over here, I also have to balance it out and get rid of it over here, right? So now I just have a one-step equation left. What will be my final step to solving this? Carter? Divide by negative 5. Divide by negative 5. So my final answer is negative 3 equals W. Right? So we're still using inverse operations. We just have an added layer of fun where we have to get all the variables to the same side. Notice I didn't do any dividing here. I didn't do any multiplying. I just added or subtracted this whole term to the other side. Okay? And then I could continue that all my variables were separated. All right, let's go on to example 2. 2.5x plus 6 equals 4.5x minus 1.
Are you going to use decimals?
We can use decimals.
Like,
We're
you
just
can't
going
have it in the answer.
Try not to have them in our answer.
Oh.
Now, if this happened to have decimals in the answer, I'd be okay with that because there are decimals in the question. I get upset when you guys take a fraction and you turn it into decimals unnecessarily. Right? Audra, you going to be okay?
Yeah, I'm good.
Okay.
Whoa.
So again, what? Oh, that's Mr. Slopeface. That's for algebra. Yeah, Mr. Slopeface. You guys will get to know Mr. Slopeface too, but just not yet. That's second.
I learned that last year in Mr. Yoder's class. I just read it. He looks kind of
Yeah, he looks kind of soft. You gotta vote him out.
He's having a rough day. He's having a rough day.
I vote red. He looks like the imposter, man.
I got
He has to
black.
go.
I got black.
No, hey, I'm black.
Okay, we're moving on. If you recall, I am making a recording for our students at home.
Oh, I forgot about that. Sorry.
Sorry.
You get to hear us saying my bad.
Okay, so I have x variables on the left and I have x variables on the right. We need to get all of our variables to one side. So this is where you get to make a choice. You can either subtract, because I have a 6 here and a negative 1 here, I can move this over here or I can move this over here. I'm going to try to keep my values positive though. So if I subtract 2.5 from both sides, I'm going to end up with positive 2x. If I subtract 4.5 from both sides, I'm going to end up with negative 2x. You'll still get the same answer, whichever way you choose to approach this. But I'm going to encourage you to look ahead and try to strategically make sure that your number with your variable is not negative. Alex?
What happened to the W, man?
It died.
The W?
Yeah, like the last question. What happened to the W? I like the W better.
You can use whatever variable you want.
Can I use?
As long as you're, I would not advise using like an S because those look like 5s, but I just choose X's and letters that look not like numbers.
Yeah, but X looks like a multiplication.
And W looks like a
Okay.
tree that looks going up.
We're going to move on. All right. So like I said, I'm going to encourage you to try to keep this number in front of the variable positive. So I'm going to subtract 2.5 x's from the left and subtract 2.5 x's from the right. Now I'm left with 6 equals 2x minus 1. And now I have a two-stepper, right, which we're all very familiar with, comfortable with. So, Marissa, what's going to be my first step here? Okay, we'll move on to someone else. Come over here and get paper towel. It's okay. Sydney, what's going to be my first step?
You're gonna add 1 to both sides.
Yep. So I'm going to have 7 equals 2x. And then my last step is going to be what, Tanner?
Divide 7 by 2 and 2x by 2.
Yep, now these are gone. So I'm left with 7 over 2 equals x. I'm going to leave it like that as an improper simplified fraction. Okay. Questions?
It's pretty much the same thing, just backwards.
We just have, yeah, and we just have one added layer to solving these equations. All right, let's do our last example. 3 times the quantity x minus 7 equals negative 4 times the quantity 5 plus x.
This is big brain.
Okay, so I'm going to draw my wall of equality. Remember, that's my reminder that when I cross over, I have to do inverse operations. So what's going to be my first step here? What do I need to apply, fix? What should be my first approach? Daniel?
So you just do what you normally would do. Do like the you know you do for 3x on both sides.
I'm going to distribute, right? I got to use my distributive property first. So then I'm going to get 3x minus 21 equals negative 20 minus 4x. Okay, so now I have to make that decision. Am I going to add 4x to the 3x and move it over here, or am I going to subtract 3x from the 4x? Which one would give me a positive coefficient? Which one will make that number in front of the variable positive? No. I'm just looking at the x's right now. I have to rearrange them. Am I going to add 4x over here or subtract 3x over here? Either one is okay, but I personally would add the 4x, so I have a positive 7 instead of a negative 7. Okay, so I'm going to choose to add 4x over here. Again, Finn, if you had done subtracting the 3x, you're going to get the same answer ultimately. You just have to worry about that negative, which I prefer not to do. Okay, now I have a two-stepper. Audra, what's going to be my first step?
Add the 21.
Yep, I'm going to add 21 to both sides because that's the inverse. Now these are gone, and I have 7x equals 1. And then I divide by 7, so x equals 1/7. And I leave it like that. I don't change it to a decimal. I'm sorry?
Like, why are there so many decimals? Like, where? You said decimals.
I said don't change it into a decimal.
Oh.
Yeah, I like it. I need you to leave it as a fraction. That's a good strategy for algebra. Okay, so what I need you guys to do now is open up Canvas and go. Just stay on my home page. Do not click on week 11. Just open up Math Canvas, stay on the home page. And on the home page, you'll see where there's that little picture that says electronic resources. It looks like a little pile of iPads. Click on that where it says electronic resources. And then once you've clicked on that, choose chapter 1.
Is this still part of the video?
I'm sorry? Yes, this is going in the video.
Because when I was watching the video, I could not hear anything. I could barely hear it.
Oh yeah, you can barely hear like the other kids talk.
Oh, okay.
Oh yeah, like at all.
All right, now, you don't need to open this in Notability. You're just going to scroll until you get to page 23. Page 23, so when you look at, go back to the home.
No, this electronic resource.
Okay, scroll to the top, click on electronic resources. There you go.
Oh, that's
And then
Good idea.
scroll until you get. So page 23 in the book is not the 23rd page in that document. I don't think.
He's grinding.
Yeah.
On his
So,
watch.
but just, yeah, it's weird. Page 23 in the book is not considered page. Did you open it in Notability?
No.
Oh, she did that. You went.
Okay.
No, do not put it in Notability. On the next page of your notes, we're going to do some practice problems. So just turn to page 28, maybe? Whatever the next page is in your notes. And I want you guys at the top. So this is going to be 29 actually, because this was 28. At the top of page 29, I want you to write this. Page 23 in the book. And then I want you to write these numbers 6, 7, 8, 10, 11, 12, 15. Those are the numbers you're going to work on right now on that page in the book. 6, 7, 8, 10, 11, 12, 15. Okay. So we're going to do a couple together, and then you guys are going to be on your own to finish these up the rest of the class. I need somebody to tell me what is the question for number 6. So you're going to number it, you're going to write the equation, you're going to solve it on this paper. What is the equation for number 6? What is it, Marissa?
M minus 4 equals 2.
Is it M or N?
M.
M? Okay. So here's our first equation. Everybody should have this written in there on their page. Okay. So I'm going to draw my wall of equality. Someone tell me what's hiding in front of this M right here?
1.
A 1. Right? There's always a secret 1 hiding, even if it's not there visually, it's there mathematically. So because I want to keep with my positive variables, my positive coefficients, I'm going to subtract the 1m from both sides. And I'm going to end up with negative 4 equals 1m. I could stop here, or I could show that I'm going to divide by 1 on both sides, and I get negative 4 equals m. Right? Let's do number 7 together. What is the equation for number 7? Alex, thank you.
3k minus 1 equals 7k plus 2.
Great. 3k minus 1 equals 7k plus 2. Make sure you have that on your paper. And then we're going to draw our wall of equality. What should I do next, Henry? Should I subtract 3k from both sides or subtract 7k from both sides?
3.
Yeah. So then I have a positive 4 instead of a negative 4, right? Again, if you chose to subtract 7k, it's not wrong. It's just going to take a little bit more thought when you have a negative coefficient. So now I have negative 1 equals 4k plus 2. So I have my two-stepper. Evan, what should I do next?
I guess,
The wall.
I'd say subtract 2 of those sides.
Perfect. Exactly. Subtract 2 from both sides. So now I have negative 3 equals 4k. Derek, what's my last step? How am I going to get rid of this multiplying 4? What's the opposite of multiplying 4? I'm going to divide by both sides by 4. Excellent. So negative 3/4 equals k is my final answer. Any questions before you do the rest of these by yourself? So again, then you would copy number 8 down and then number 9. Oh, excuse me, not number 9. Don't do number 9. I had a lot of students yesterday that tried to do number 9. It has fractions. We haven't talked about fractions yet, so don't do that one.
I'm not saying I do, but like if I did not do it,
You can try it.
I don't know. It's on